Hello guys, Jagveer Singh back with another video of Mastercam 2020, and in this particular video I'm just going to continue the same part that I made in last video as we completed the wireframe. So in this video I will show you how to convert the wireframe into a solid, as well as some practical applications of enhancing your efficiency within the software itself, and also making it more practical and more practical application based. So what I mean by application based is that if we think about this particular part in real life, if we do have to make any part in any kind of manufacturing, whether it is mechanical, aerospace, or any high precise machining, they always recommend you to have non-sharp edges. So the main reason about that is that sharp edges is the initiation of stress, and definitely wherever it is stress, it becomes easy for any part to break or crack, which we definitely don't want in any kind of industry, whether it is mechanical, aerospace, or whatever kind of infrastructure that we are trying to make or manufacture. So we have many stress points or sharp edges. As we can see, we have 1, 2, 3, 4, 5, 6. Well, we can neglect this one because this will be automatically covered under the curvature. And we have 1, 2, 3, 4, 5, and the sixth one is at the very end. So out of these 6, 5 of them, which are 1, 2, 3, 4, and the last one, these can be compensated by the tool, which I will show you in further videos. But in this particular video, what we can control just within the wireframe is the very first one and the very last one within the wireframe. But I will recommend not to use the last one or make changes to the wireframe. I will tell you a technique that you might be willing to learn and use if you need it. So the first one, in order to make it smoother, we add chamfers. So I go to wireframe, I click on modify, and under modify I have chamfers. I click on chamfer, and I'm just going to add any random chamfer because I don't have a specific drawing which is stating me to make a particular chamfer if needed or wherever possible. Otherwise, it's in every drawing it is going to be mentioned that all the chamfers should be of this particular dimension. So we need to make sure that we follow the drawing carefully. So I added the chamfer right here, and now what we are going to do is we are going to do 2 operations in this video, or maybe 1 operation. Let's see how much time are we going to take in order to explain. If it's going to be too long video, then I will split this video into 2 parts, in which I'm just going to explain facing operation and then the roughing operation. If I'm able to do it within time, so I will just make 1 video which is going to be consisting of both facing and roughing operation. So let's see. So the first step is going to be that we go to machine under the lathe, because this part we are working is lathe, not mill. We have other options as well, which is wire or EDM, router, and design. So lathe is the one that we are going to bring the machine group in. I already have a machine group, but I still want to make it in front of you guys just to let you know like how exactly to bring it in. So I click on default. So I have 2 machine groups. I'm going to delete the first one. So I click on the machine group and I click delete. So the second machine group, the one that I just inserted right now in front of you guys, it have subgroups of properties. When I click on properties itself, it has 3 subgroups: file, tool setting, and stock setup. So file and tool setting are factors that might be determined in the drawing, or depending on the operator itself, whatever is convenient. But some factors like files that we can replace for the machine tool path, we can go and try to find out if you think which one is going to be preferred. You can choose from many other files, but I would recommend you to always verify if you're not sure. If you are new to this software, then just leave the settings to be default or ask someone who is professional, or if you are really very curious about it, then please let me know in comment section if you have any doubt by choosing like which file to choose whenever you're going to work with the software itself. So I have lathe default millimeters, which is the metric, and basically I am working in metric, so that is the settings that I'm looking for. I will also recommend you to go to edit. If you understand the software properly, you can always go to control definition, and under control definition there will be an option of NC output. It might take some time, and there we have NC output. And right here I'm going to increase the maximum sequence from 9999 to 7 times 9. So 1, 2, 3, 4, 5, 6, 7. So this is basically for your G code that is going to be generated, so that it doesn't run out of the number of lines while generating the G code. I click yes and I click OK. So I move on to tool settings. I can always toggle just between file, tool settings and stock setup right here, or I can click OK because I'm already done with this part, and then also toggle between these three options on the screen itself under the machine group. But this becomes easier because all I need to do is click and toggle between them. So this is what I prefer you guys to do as well. So feed calculation by default it is going to be from tool, but I will recommend you to choose from material, because all the feed calculation when done from material is considered better, because once the software knows that what material you're working with, it helps you to identify some specific values of feed and speeds which are pretty good as per the material, and you can rely on those parameters in order to make sure that the operation doesn't result into crashes or failures. But you also need to have a good understanding of what exactly feed and speeds are. So if you have any doubt in that, you can always contact me or have a tutoring session as well. So I'm going to turn all of these four options on, not the last option. I will tell you in upcoming stages that what is the main reason. So similarly, override. So clearance height is the height at which our tool is going to stop before start to cut our material, our raw stock material. So clearance height, I'm going to turn it on. Retract height is the height that after each operation our tool is supposed to go and then retract back to its original position. I'm going to turn this thing on too. And the feed plane is just the plane right above the part at which we want to make sure just before the cutting phase that everything is under control of the operator. We also have the option to choose the material. Let's say we have different options, so we can choose between, we are working with lathe, so lathe library, and we have all kind of material. So I'm just going to stick with aluminum 2021, so I click OK. So default program number is very important, especially when you have the drawing number is basically the default program number, and it makes you understand that which particular G code belong to which particular drawing. So that helps in organization also. I'm going to consider it to be 1111, let's say. Then I go to stock setup. So in this case we have different options. As you can see that this is going to be our left spindle. So the stock properties, we need to make sure like exactly what are we looking for. So we click on properties, and in this particular case it's asking for the outer diameter. So we know that the maximum diameter we have is 30. If we are not sure, we can always click on select and then select the maximum heighted line, which is this in our case. It can be a point or a line itself. So it already told us that it is the outer diameter is going to be 30. Similarly, the length is going to ask. So we know the length is 60 by the drawing. If we are not sure, we can always go and click on select as well. So in this case, it is going to select the length of the line that you chose. So it can be kind of hard to predict what exactly length it is going to pick. So I will recommend you to enter the value by yourself if you are sure about what exactly the value is going to be. Just like in every drawing, it will be given what is the length of the part. So I would recommend you to choose that length. So 60 right here, and on the Z position we can say it to be 0 right here. And there, we in this case we are going to use margins. So what's the purpose of margin is that we are looking to have some extra material for the facing in order to set up our origin. So what does that mean is when you are thinking to cut a particular raw stock material, so in this case now you have to think some practical based applications too. If you have a raw stock material and you want to cut that material, initially you need to specify where your origin is going to be for that particular part, which is most of the time we take it to be at the very top, at the very beginning, right here, right here. So similarly, I need to make sure that all those parameters are good. For the same, I will leave a small portion of, let's say, 0.5 millimeter, which is pretty small, to be my margin, and I'm going to cut the part according to that. It can be 0.5, it can be 1, or whatever the amount, depending on how much are you willing to cut and you can afford to cut the material. For the length, if you're not sure, so the length I will recommend to keep it higher. I will tell you the reason as well, but just to make sure how it's going to look like, I'm just going to click OK with all the parameters that I have inserted. You can see the shaded line right here. It gives me an idea of how my stock is going to look for this particular part. If I zoom in, see I have a slight material which I have kept for 0.5 millimeters, which is on the right hand side of the part that we actually want. So just imagine, so I'm going to maximize the screen. So just imagine a tool is going to come from this side, from the right hand side, and try to cut this particular material which is in cylindrical in shape to this particular shape which we have made using the wireframe, and we'll get rid of the excess material every time. But we also need to make sure that we don't have any excess material right here in order to hold within the machine. Well, if you have ever gone through a CNC machine for lathe, it always consists of a holder. Just let me go and check once again and show you like what exactly it looks like. So if I say that I do have a particular, let's say I search here CNC lathe. So you can see the CNC lathe come in many varieties. If I say CNC lathe chuck, it will show you how exactly the part will look like within the machine itself. Right here. So CNC chuck, it looks something like this inside the machine. So you need to insert this particular raw stock material inside this chuck so that it can hold your part that you want to cut. So you can see that these jaws, these are called the jaws, and these jaws are going to be tightened up in order to hold the part. But this also have some space which you need to compensate with your stock material. So that is the reason that we need to increase the length by a certain amount. Most of the time, the general formula is it is 3/4 of an inch. The jaws, the holding jaws are going to be 3/4 of an inch, which are recommended standards in machining and manufacturing. So what does that mean is that if you do have a 3/4 of an inch, which is going to be, let's see when we see in millimeters, I calculate, so 3/4 of an inch is 0.75 inches. In order to convert into millimeters, I need to multiply by 25.4. So I'm looking for 19.05 of the compensation. And also for other compensations, I'm just going to consider it to be, let's say, 20 to 25 millimeters if I want to. So if I have 19.05, I'm just going to go for 21 millimeters of the total length that is required for me to add within the exact length that I have right now. So let's say I'm going to add 21 millimeters in the existing stock length, which is right here. Stock length we have 60, so I'm looking for 81, or just to be rounded off to close fifth, I'm going to write 85 as my length, and I'm just going to make the right margin to be 1 and click OK. So here you can see that I increased the stock material in order to hold the part, and also it's going to help me cut off some extra material to have a better face, a smooth face, so that I have a proper origin from which I can have all the other dimensions referenced. So now we have the stock material ready, and now we are ready to machine itself. So I go to turning. So under turning, I have different options to choose. The first operation always is going to be the facing. So you drag down, you have face, you click on face. So the tool we are going to use is going to be right-handed tool. Well, it all depends on the kind of machine that you're working with. If your machine have the tools on the left hand side, then you have to choose left hand tools. It all depends on configuration of your machine itself. In most of the cases, in approximately 90% of the cases, the machines are going to have right-handed tools, and the parts are going to be loaded on the left side of the machine itself in order to have the manufacturing process on. So 80 degrees is the tool that we are going to use. So what exactly 80 degree is? Let me double click on the tool. So 80 degree is basically the right here. So the angle that we have of this particular tool in real life, if you see an 80 degree tool, so this angle is very close to 90, but it is not a perfect 90. It is made to be an 80 degree so that it can heavily cut materials. It is not that sharp of an edge, but it can actually do some damage if we try to be careless around this tool. But it is mainly used to cut a chunk of material in one pass so that we can have some room for finishing, which I will show you in next video what exactly finishing is and talk more about it. But for now, we are working with facing, so I'm just going to stick with the right hand tool, which is for 80 degrees, and the 80 degree is going to be the roughing tool, plus the same tool is going to be used for facing as well. So facing and roughing is going to have the same tool as I told you. So it is really important to take note of that. First thing, that it should be a right tool and it is 80 degrees. You can also use 55 degrees, but it all depends on the tool that is available to you inside the machine shop or the workhouse. So tool number is given with respect to a tool list, which is always provided in your workshop, because that specifies that what exactly tool is present in the tool turret that you have inside the CNC machine, and allows you to make adjustment according to your tool list. That's why a specific machine will always have a tool list in which it will show you that what particular tool is inserted in which turret column, so that it becomes easier for any CNC manufacturer plus the person who is going to design the G-code through Mastercam to understand and study that which tool goes to which place, and according to that he or she doesn't make any mistake while making the program. So I'm just going to stick with the default values here, 1, 1 and 1. So feed rate, it all depends on the kind of cut. I'm going to stick with all the standard parameters, and I will turn on the coolant. Click on coolant and turn it on. Click OK. Well, all these parameters depend on the kind of tools that you have and also on the capability of machine. If you have pretty strong machines like has machines, then for sure you can play around with close to 7 to 10,000 of RPM. But at the same time, if you don't have those kind of machines, and if you're working with machines like Tormac or some other local machines which are not that heavy duty, then the RPM can also vary according to the price of the machine that you have or the quality. So it is all dependent. Spindle speed, I can have it to be 400. For the facing, it doesn't matter, so it's just going to cut the extra material that we kept. Face parameters. So the entry amount is going to be whatever we kept to be, let's say 1, and we are going to cut, all the other parameters can be left as standard, so it looks good, and I click OK. So now you can see that my excess material of 1 millimeter is cut down, and right here we have completed our first operation. And let's see how it looks like. You can always select all the operations. We just have one operation which is already selected, and click on verify selected operations. If you just want to make sure that how the tool path is going to work just in this scale, you can always click on backplot. So backplot shows you how the tool is going to work. So I'm going to decrease the speed right here, and I'm going to click play. So you can see the tool will be appearing. I'm just going to slightly increase the speed until the tool arrives. And there is our 80 degree, and there it goes and does the facing of the part. There we go. Also, if you want to do it verify, you can click on verify, and it will make an actual representation of how your part is going to be inserted within the machine and how will it look like, just like this. An isometric view. I will decrease the speed. Always a recommended suggestion: stop condition, collision, if there will be any collision, the operations will automatically stop and it will give you a warning that there is something wrong with your tool path. So it is very beneficial as it avoid a lot of collision in real life. You can go to verify just in order to have different colors for each operation, just to distinguish. You come back here and I can go to top face again and click. So it just cut down the excess material that we had, and we can see that this is our first operation because it turned from gray to yellow. So that's going to be color for our first operation. So here I think I forgot to add the dimension along the diameter. That's why I'm able to see one line here. So it is very important that even in the diameter we add some parameters just to have some extra material. So I will quickly go back to the stock itself and add few millimeters on the outer diameter itself. So I had chosen 30, but I forgot to add some extra material on the diameter itself, which I'm going to do it, let's say 35. Click OK. And now I do have that. So after I make any change to stock material, you can see that the stock material turned red from grayish dotted line, it turned red dotted line, and you can see a cross in my toolpath. To regenerate it, what you can do is you can select all operations and you have regenerate all selected operations. And now we have again the same thing, which looks good. We can verify it again, and now I'm pretty sure you will not be able to see the black line right here, just like I said. And when I'm going to play it, and there we go, our first operation for facing is done. So yes, so that was it for this particular video. I hope you enjoyed, and in next upcoming video I will show you other operations like roughing, finishing, and various other. So stay tuned, and don't forget to like, subscribe, and share this video plus the channel. And also I will try my best to upload as many videos as possible by end of this month. My daily goal is going to be one video each day. So please show your support. Don't forget to like, and also please subscribe to my channel and share it with your friends as much as possible. Thank you.